Dear students, welcome to the sixth lecture of 8051 interrupts. So in the last fifth lecture we have seen how we can program the timer interrupt. Now we'll see how we can program the external hardware interrupts. So as you know, in the last few lectures, the 8051 has two external hardware interrupts. Okay, two external hardware interrupts, and the pins that we are using here is pin number 12, and it is represented with the pin 3.2, the third port second pin, and this is nothing but INT0, interrupt 0, and the address that they have given is 0003H IVT address, that is interrupt vector address. And one more interrupt, one more external hardware interrupt, pin number 13 P 3.3. From this pin we are getting the interrupt signals, right? Pin 3.3, that is INT1, it is denoted by INT1, and the address for that is given as 0013H IBT address. Okay, so how the interrupt is occurred, how the activation of these two external hardware interrupts are done. So upon activation of these pins, the 8051 gets interrupted, right, in whatever it is doing, and jumps to the IVT to service that particular ISR. Okay, so now the two external interrupts, INT0 and INT1, the two external interrupts INT0 and INT1 can be enabled or disabled using I register, as I talked in the last lecture. Okay, so how they are activated, how these two interrupts are activated. So there are two ways, two types of activation levels for external interrupts. One is level triggered and one is edge triggered. So we can activate these two interrupts either by using level triggering or by edge triggering. So let us look one diagram here. So let us take INT0. Let us take INT0, that is with respect to pin 3.2, right? That is with respect to pin 3.2. Okay, so here I have written one diagram. If I make, usually INT0, it is represented by INT0 bar here, right? So usually it will be in the lower state. When I will put is equal to 0, when the input is equal to 0 here, then the output will be equal to 1. So this is called a level triggering, right? INT0, right? INT0 is nothing but, if I put 0, if I send the low level value inside INT0, then the value of that will be equal to 1. That means the interrupt is occurred at pin 3.2, and it will go to the address, IVT address 0003H. As I said here, the INT0 is having 0003H, right? So it will move to the 0003H and it will execute the instructions with respect to the ISR, and it will go back to the main program. So this is the case of level triggering, right? So if I take edge triggering, what has to be done is, if I send the signal from high to low, send the signal from high to low, right? So here I am using the bit called IE0. So this bit is there in the TCON register. You can refer TCON register, the bit number 1. So when I send the signal from high to low signal, this is called high to low signal edge triggering. So this is called the edge triggering. Again, it will fetch the address 0003H, and it will execute all the instructions with respect to the ISR, and it will move back to the main program. So this is about INT0 bar. So similarly INT1 bar. So the same process here I have written. Here IE1 bit is used in case of edge triggering, that is tcon.3. Okay, so the address that we have to write here is 0013H. So this is the basic about the external hardware interrupt. Now I will see in detail the level triggering, how actually the level triggering is done. So the title is level triggered interrupt, right? So first I will read out the statements. In the level triggered mode, INT0 and INT1 pins are normally high. Okay. If a low level signal is applied to them, it triggers the input. So here I will show it how we can do it. Do is INT0 bar, when I will put 0, that is called by the name called low level, then the value of INT0 becomes equal to 1. That means the programmer will come to know that the interrupt has been generated. Okay. So when the value of this becomes equal to 1 after sending the low level to this particular pin, it will fetch the address. Where it will fetch the address? Using the IVT table, right? So after getting the address, the flow has to be given to ISR, right? Interrupt service routine, and the instructions with respect to the interrupt service routine will be get executed until RETI, return from the interrupt. And after the return from the interrupt, it will move to the main program. This is how the process is done in level triggering. It's very simple, just to send low level signal. Okay. So the same thing I have written here. The low level signal at INT pin must be removed before the execution of the last instruction of ISR. Please take care that the low level signal at INT pin must be removed before the execution of the last instruction of ISR. So whenever I have put the low level here, it has to be removed before the execution of RETI in ISR. Otherwise, another interrupt will be generated. If I won't remove 0, then automatically one more interrupt will be generated inside the ISR. So in order to overcome that, we need to remove this low level signal before the execution of RETI. Hope this statement is clear. So next, what is the time taken? What is the time taken to activate the low or the level triggering? So the time taken is, so we know that one machine cycle, if the crystal frequency is 11.0592 megahertz, if the crystal frequency is 11.0592 megahertz, we know that the one machine cycle will take 1.085 microseconds. So 8051 will take 4 such type of machine cycles to execute 4 into 1.085 microseconds. 4 machine cycles, 4 low values. So this is a low level, low values, right? Low value, right? To execute the low level triggering interrupt. So this low level has to be given to INT0 bar. So how much value is to be given? 4 into 1.085 microseconds. So it will take this much amount of time to go into the level triggered interrupt. So here I have written one statement: on reset, INT0 and INT1 are both low, making external interrupts level triggered. The meaning is the minimum duration of low level triggered interrupt, the minimum duration, the low level triggered interrupt takes 4 into 1.085 microseconds, and hence I have written like this. So one machine cycle will take 1.085 microseconds, right? So this is high signal and it will come to the low level signal. So it will take 4 machine cycles of that, right? 4 into 1.085 microseconds. So it will take this much amount of time to trigger, to enter into INT0, INT1 pin to make the value is equal to 1. So this is about level triggered interrupt. You just go through this video once again, and if you have any questions you can ask. And now let us move to the next, that is edge triggered interrupt. Edge triggered interrupt, it's very simple. So to make INT0 and INT1 edge triggered, we must program the bits of TCON register, as I said in the last here while dealing with the program. While dealing with the program, if we want the edge triggered interrupt, we need to program this particular bit. It's very simple. Just we need to set these two bits. That's it. That only I have written here. So to make int 0 and int 1 edge triggered, we must program the bits of TCON register, timer control register. You just go back to the timer control register so that it will be more clear. So upon reset TCON.0, that is a bit IT0, and TCON.2, that is bit IT1, are both 0, meaning that the meaning of this is equal to 0 and this is equal to 0, meaning that int 0 and int 1 pins are low level triggered, as I discussed in the last session. Okay, by making TCON.0 is equal to 1, that is TCON.0 is equal to 1 and TCON.2 is equal to 1, int 0 and int 1 becomes edge triggered. Just we need to make these two values equal to 1, that's it. That is nothing but the edge triggered interrupt. So this can be done with the help of the instructions. We need to write the instructions. In order to do these two values equal to 1, we need to write set B. In order to make any one bit is equal to 1, we need to write set B space TCON.0, set B space TCON.2. That's it. After writing these two instructions, then the programmer will come to know that we are using edge triggered interrupts. The programmer is using edge triggered interrupts. That is 1 to 0 high to low level signal is applied to pins P3.3 or 3.2. The microcontroller will be interrupted and forced to jump to IVT to service ISR. The same statement that I have written here. And the minimum pulse duration to detect edge triggering, it's very simple. So one machine cycle is needed. One machine cycle, that is 1.085 microseconds. So this is the edge triggering interrupt. So this is 1, this is 0. 1.085 microseconds. So only one pulse. So 1.085 microseconds, that is 1, and 1.085 microseconds, that is 0. So only this much minimum pulse duration to detect edge triggering, that is sampling value is for 1 to 0, this much amount of time it is needed. But for level triggering, we need 4 into 1.85 microseconds, because we need to send the low level signal right to the pin. But here directly we are writing the instructions set B TCON.0 or set B TCON.2. So I need only one machine cycle to go inside the edge triggering interrupt. Okay, minimum pulse duration to detect edge triggered interrupt if the crystal frequency is 11.059 megahertz. So this is about the edge triggered interrupt. If you get any questions, you can put the comments. I will answer. Thank you.